Okay, class, welcome back. We're going to continue with the factoring, but for these we are going to solve quadratic equation. So it's a quadratic because it's a degree 2 polynomial. You see that it has something squared, so I know that it's a squared, and then it's an equation because it has an equal sign here. So we are going to, when we solve these, bring all terms to the one side of the equal sign. We're going to always factor out the GCFs just like we did with factoring. Then we're going to factor it, and then we're going to set each term equal to 0 and solve for our variable. And we are never, ever, ever going to divide by a variable. Okay, so for this first one, we're going to factor it. So we can do it factoring with the box method, or you can notice that this is a special factoring pattern that we learned last time. So this first term is 3y squared, and my last term is 2 squared. And my middle term, which is negative 12y, that is twice the product of my 3y times my 2. And it's negative, so it's negative 12y. So it is. So it factors as the special factoring from before. So I know that this can be factored as 3y, because you take your first term, you take whatever your sign is, and you take the square root of the last term, which is 2 squared equals 0. 0. So then this is 3y minus 2 squared, which is the same thing as 3y minus 2 times 3y minus 2. Squared means write it out twice. So we factored it. We're going to set each term equal to 0. So we're going to set each of these factors equal to 0. So 3y minus 2 equals 0. And again, we're going to have the same thing again. 3y minus 2 equals 0. 1 for each factor. Going to bring 2 to the other side and divide by 3. So y equals 2/3. So we're going to get that answer twice. Okay. Let's move on to the next problem. So the next problem says solve this equation. So first step was to bring all terms to one side of the equal sign. So I'm going to subtract 3x and add 6 to both sides. I'm going to subtract 3x and add 6 to both sides. So I have 0, because the 3x's cancel and the 6's cancel. X squared minus 3x. And when I combine my like terms, I get negative 4. So I set it equal to 0. I'm going to factor out the GCF, which there isn't any. So I'm going to factor. You can factor with the box method, two numbers that add to be negative 3x and multiply to be negative 4x squared. Or some of you can just see that it factors as x minus 4 x plus 1. If you don't see that automatically, you should definitely use the box method. But if I use FOIL to check, the first gives me x, the outer gives me x, the inner gives me negative 4x. So negative 4x of my inner combined with my outer of x gives me my negative 3x. And when I multiply by last, I get a negative 4. So I factored. I've checked that I factored it. So I'm going to set each factor equal to 0. X minus 4 equals 0. And x plus 1 equals 0. So I get x equals 4. And x equals negative 1. And those are my two answers for when I solved it. Okay, let's move on. So let's factor these two. So I'm going to bring all terms to one side of the equal sign. So I'm going to subtract 5 to the other side. So I end up with 3x squared plus 14x minus 5 equals 0. It's not one of my special factoring patterns, so I'm going to have two numbers that add to be 14x and multiply to be the product of those two, which is negative 15x squared. So the numbers that multiply to be 15x squared would be 15x and 1x. So I know 15x minus 1x will achieve that. So you put your 15x and your 1x in your diagonals. You put your first term in your first box and your last term in your last box, so the first and the last of what we're factoring. You pull out your GCF, so they both have a 3x in common, they both have a 1 in common. Column 1 has an x in common, and column 2 has a 5 in column. When I put my x in, I really should have put a negative x here. And remember, if it's a negative sign here, you're going to pull out a negative 1. And double check that you multiplied everything correctly. So 3x times x gives you 3x squared. 3x times 5 gives you 15x. X times negative 1 gives you negative x. And negative 1 times 5 gives you negative 5. And when I combine everything in my box, I do get what I wanted to factor. So this factors as x plus 5, 3x minus 1, and I still have this equals 0. I just factored the left-hand side. So I'm going to set each equal to 0. X plus 5 equals 0, and 3x minus 1 equals 0. So I'm going to solve for my variable. X equals negative 5, 3x equals 1, or x equals 1/3. So I have solved this. X equals 1/3 and negative 5. Okay, next one. It's already set equal to 0. That was the first step. Then I'm going to factor. And before I factor, I have to pull out the GCF. So I notice they both have a 4u in it. So I'm going to pull out a 4u, and I'm left with 16u squared. Oh, sorry. That's not 16. Let me pause this. Okay, so 4u times what I have left when I pull a 4u out of my 4u cubed is a u squared, minus 4u goes into 64u 16 times equals 0. And I notice the u squared and the 16 is a difference of squares, so it factors as 4u times u minus 4, u plus 4 equals 0, because you take the square root of the first and the square root of the second, and you make 1 minus and 1 plus. Then you set each of these 1, 2, 3 terms equal to 0. So I'm going to continue the problem up here. So 4u equals 0, or u equals 0. Then the second factor is u minus 4 equals 0, which tells me u equals 4. And finally, the last factor, u plus 4 equals 0, tells me that u equals negative 4. So we have 3 answers, and you can write them. U equals plus or minus 4 and 0 are our 3 answers for that problem. Plus or minus 4 and 0. Okay, let's go on to the next problem. So the next problem is a word problem. So it says a painter is making a rectangular canvas for her next painting. Okay, so it's going to be some sort of rectangular canvas. She wants the length of the canvas to be 4 more than the width. So we're going to have some length and some width. And I know that the length that she wants has to be 4 more than twice the width. So I know the 2w plus 4 is my length equation. And the area of the canvas must be 30 square feet when I find the area. So I know that the area formula is length times width. And the area needs to be 30. My length equation is 2w plus 4, so I'm going to plug that in. So 2w plus 4 times w. So I'm going to factor this, but first I have to set it equal to 0. So I'm going to distribute my w through. So 30 is 2w squared plus 4w. I'm going to subtract 30 to the other side. So 2w squared plus 4w minus 30. So now I set it equal to 0, so I have to pull out the GCF. They all have a 2 in common. So I'm going to pull out a 2, so I'm left with a w squared plus 2w minus 15. And this isn't a special factoring pattern, so I'm going to use the box method to factor. So I'm running out of space, so I'm just going to carry on here. So I left off at 0 equals pulling out the GCF of 2 and having left over w squared plus 2w minus 15. So I can start off by dividing both sides by 2 so that those cancel. So I have 0 is w squared plus 2w minus 15. And you can use the box method, so two numbers that add to be 2w and multiply to be minus 15, and you put it into the box. You can see that this is w plus 5 times w minus 3 when I factor it. And you can FOIL it to confirm. Then I'm going to set each equal to 0. W plus 5 equals 0. W minus 3 equals 0. So I get w equals negative 5, or w equals 3. Now, this is talking about the length and the width of the canvas, so we clearly can't have a negative width. So I know that w is going to equal 3. The question asks, what should the dimensions of the canvas be? Well, I found the width, so now I have to find the length. So I know the length is 2w plus 4, so 2 times 3 plus 4, which is 10. So the dimensions are 3 inches by 10 inches for our width and our length. And that would be our answer. And that would be all.